here we are going to discuss some of the problems. Okay, so here mostly we will see how to identify the flow. Here what they have given the u.
Ma'am, option D, ma'am.
See, how will you resolve? The given data is u is given a e power x. What they have given in the question, they have said the flow is two-dimensional, okay, incompressible, steady flow. That means what formula we have to satisfy? Continuity equation. Dou u by dou x plus dou v by dou y equal to 0. Okay. Now dou u by dou x equals to minus dou v by dou y. Now what is dou u by dou x? If you differentiate this one, what will be the value? You will get a e power x. Will you get the same value? You'll get the same value, isn't it? So substitute over here a e power x equals to minus dou v by dou y. What will you get? Dou v equals to minus of a e power x into dou y. Integrate both the side. V equals to, you will have minus a is constant, it will come outside. Integration of e power x will also be same into y plus function of, since we are integrating with respect to y, then we will have the function of what? Function of x. Now tell me, what is the right answer? What is the right answer now? Now we have the option C. Okay? All right? Clear? Is it clear to all of you? Let me know.
Yes, ma'am.
Okay. Shall we move to the next question?
Yes, ma'am.
Okay. Okay, I was telling one more important point. Just let me take the ink. Okay. There was a velocity potential. I request please mute yourself. Okay, thank you so much. Then stream function. Okay, velocity potential and stream function. Now velocity potential is three-dimensional and stream function is two-dimensional. Now there was a question that they have given some u function has been given and v function has been given. Now they can also ask a question whether this particular flow, okay, u and v will satisfy the velocity potential or not. Now to understand that whether this will satisfy, first you need to understand velocity potential is such kind of flow which has to be a irrotational. It has to be a irrotational. But stream function, it can be rotational or irrotational. Okay. So how to find irrotational? That means this is a function. That is dou v. First, then we'll have the x, then we'll have the u by y. So if it is equals to 0, that means if the angular velocity becomes 0, then only we can say that this particular u and v will satisfy the velocity potential or not. So you can expect such kind of questions also. I hope you got the point. Like previously we have some equations like x minus 4y, then minus y minus 4x, something like that. You got a question. Now it may depends on the function, u and v function, whether it will satisfy or not. Okay. If it does not satisfies, that means if it becomes not equal to 0, that means it will satisfy the stream function, but not the velocity potential. But not the velocity potential. Clear? Is that clear to all of you? Let me know. Shall I move to the next? Shall I move to the next? Let me know.
Yes, ma'am. Sure, ma'am. Yes, ma'am.
Okay. Now let's solve this problem. Now solve this problem. What is the problem? A two-dimensional flow field has a velocities along the x and y directions given by u equals to x squared t and v equals to minus 2xyt respectively, where t is time. Now the equation of stream functions is, so from here you have to use the equation of stream function. Now let me tell you what is the equation of stream functions. Very simple equation. In three-dimensional, u by dx equals to v by dy and w by dz. Okay, this is a stream function equations. Now here, as they have said two-dimensional, they have said only u and v. So you can take this equation. Okay, so in that equation you can get u dv equals to v dx equation you can take, or you can take vice versa. You can also take dx u by dy by v. Now what you have to find? You have to find the equation of streamline. How will you do that? Have you started solving, or are you still thinking? Whenever you have the u and v, substitute the values. What you will do? Dx by x square t equals to dy. V is minus. We have so minus 2xy t. This t will get cancelled off. This x and will get cancelled off. So you get dx x equals to minus dy by 2y. You can also write like that 2 dx x equals to minus dy by y. If you integrate both the sides, 2 ln x equals to minus ln y. Now, if we have the ln something in front of the ln, then we can write ln x square equals to minus ln y. Here we have negative. When we bring this one here, we become positive. Ln x square plus ln y becomes here 0. Then ln something plus ln something becomes multiplication equals to 0. Now ln x square y, what is 0? Ln 1 is equivalent to 0. So you get x square y is constant. Now you get which options? This. This is a very easy one. Which one of the following stream functions is possible? A rotational flow field.
We have found that it's dou square psi by dou x square plus dou square psi by dou y square is equal to 0 now. So the second option.
All right. So let's find out how you have solved the problem. Which formula have you used to solve this problem?
That's all. Straight away, mom. It's like we have given the psi. I've taken it up to 2xy. So dou square psi by dou x square plus dou square psi by dou y square is equal to 0. It has been proved now.
Okay.
Option 2, ma'am.
So you have used this one.
Yes, ma'am. Del
Yes,
square psi by del x square plus del square psi by del y square equal to 0.
Equal to 0. It has to satisfy this.
Yes,
So,
ma'am.
so first let me try and solve it. So okay, you have to find for all the three, right? You have to find for all the three, all the four. Then only you will understand that which one is irrotational, right? Now, do you find any shortcuts in that? Now, by seeing, can you say that which one is the right answer? Can you tell me how to do the shortcut methods? See, first of all, to find the rotational, you have to double differentiate. So, whenever you will have any term less than that particular, here we have x power cube. That means somehow it will become, some factors will come after you double differentiate that. Here also you have square terms. So you will get some values. Here also we have, somewhere we also have the square terms. So anyhow it will become not equal to 0, not equal to 0, not equal to 0. Right? So this is one of the shortcut methods. First you have to see, because this is a way that you can find. Since psi is given, you have to, this will be easy one to use this formula. Here it is having the double derivatives. So when you have the no powers over here, that means this will somehow tends to 0. Right? When you differentiate the second time, it will become to 0. So in the option, look into the options. Okay, first, if you have such kind of things, first look into the options. So whichever you have the less power, start with that. And whoever having more, just ignore it there itself. Just ignore there itself. You can ignore this 3 easily by seeing the options. You got my point? This is also another shortcut methods. All of you got the point?
yes,
This is how you can save the time. You can
Yes, ma'am.
save the time. All right. Now let's move to the next question. Okay. So in this question, let's read the question. Component of velocity u and v along x and y directions in a 2D flow problem of an incompressible fluid. They have given four questions. They have given those who will satisfy the continuity equation would include. So they have asked which one will satisfy the continuity equation.
Ma'am, option 1, ma'am. 1, 2, 3.
Option 1. Okay.
Yes, ma'am.
So all of you getting the same answer?
Yes, ma'am. Option 1, ma'am.
Okay, shall we move to the next? Here comes another type of questions. Okay, here the stream function is given. They ask the magnitude. Almost the same kind. Okay, almost the same kind. So what you have to do is, again you have to find the capital V. What is that? U square plus V square. Okay. After substituting all the points, you will get the answer. Now find out and tell me the right answer. So do not look back to the formula U and V. U is minus dou psi by dou y. V is plus dou psi by dou x. 4.24. What about the others? Are you getting the same answer? Okay. Now we have another questions over here. Now this is as I have explained, it is in terms of equations they have given. So from here you have to sort it out. What is u? U is 8x cube and v equals to minus 10x square y. And you have to find whether the flow is rotational or irrotational.
I think the answer is rotational. The answer is rotational.
Sorry?
Yes, ma'am. Answer is rotational, ma'am.
It is
Because it is not equal to 0.
It is not equal to 0, right?
Yes, ma'am.
Whatever you're solving, it is not equal to 0, so that it leads to an
Rotation. The
rotational
answer
one.
is 12x square we are getting.
Yes, absolutely. Now, there is one more way to find out the flow is rotational or not. Okay, there is one
Del
more
B
way.
by del X minus del U by del Y can we use, ma'am?
Yes, this also can
Del
be
B.
used. Okay, I hope you have studied the curl vectors, right? So you can use the del into v equal to 0. If this satisfies, that means it is an irrotational. Okay, the flow is irrotational, and if it is not equal to 0, that means it is a rotational flow. Okay, so you can, using this also you can find out. Okay, all right. So now we will, yes.
I'm actually like, frankly speaking, I forgot the curl vector mark. So can you please write the curl vector answers?
Sorry, curl vectors.
Yes.
Yes, it is like, it is nothing. We'll have I, here we have j, here we will have dou by dou x, here we have dou by dou y, and in the third you will have whatever you have the u parameters, and here you will have the v. Okay, the same thing you will get dou v by dou x minus dou u by dou y. You will get the same thing, isn't it?
Yeah. That's equal to what is given.
Yes. Okay.
Sure.
All right. This is the parameter is vorticity. Okay, keep that in mind. Okay, because this is a
Yes.
vorticity equals to twice of
So the
your
angular
angular
velocity.
velocity, and that means angular velocity is half of the vorticity. And what is the vorticity at the z point? We have half of dou v by dou x minus dou u by dou y. All right. Now, what you have to do, we have learned enough of that nature of the flows. I'm quite sure if you practice this problem quite rapidly, you can definitely attend one of the questions from here. Definitely. I'm quite sure. Now, you tell me, are you all aware of these questions? Can you identify the flow? Rotational flow, computational flow, irrotational flow, steady flow.